On this second video, we're going to be using trigonometry to find angles. Here's a little formula sheet for the chapter. We know that if we have a right angle triangle and we have all sides, then the formula we're going to use is the Pythagorean theorem. But if there happens to be some sort of an angle on it, then we're going to use SOHCAHTOA, right? On the right side, we're going to be filling it in when we have triangles that are not right angle. So this is right angle, we use this too. A non-right angle, we use what we're going to find out. This we covered in the last video. So let me ask a couple things here. What is sine of theta equals 0.5 asking for? When you get something that says sine of theta equals 0.5, what are you asking for? Well, I'm solving for theta. I want to figure out what my angle is. So it's saying what angle's sine ratio is equal to 0.5. How do we go ahead and do it? Well, just isolate it. And how do I isolate it? Well, sine goes to the other side as sine inverse. Remember that we had to the power of -1 for exponents, but that's not the case. Sine of -1, it's called sine inverse, and we say sine inverse of 0.5. And we just plug it into the calculator as follows. So sine inverse, and you're going to find a little button, usually above your sine, and if you press second key, you plug it in, and sine inverse of 0.5 is actually 30 degrees. And the same idea applies for cosine and tangent. So to remember what sine theta was and what sine inverse is now, see if you can figure that out. Now, what about this question? If you walk 200 meters on your height increased by 7 meters, what is the inclination of the road? Now, I put the 200 here because sometimes we don't know if you're going to put it here or if we want to put it at the bottom. But if you're walking on it, then that's the distance that you measured. So see if you can fill this in and do it, and I'll show the answer in 2 seconds. 3, 2, 1. That's 3 seconds, I guess. So sine theta is actually a ratio. It's just a comparison of two numbers. Inverse sine, or sine inverse, actually gives us an angle. So be careful with that. So let's see. We have an angle, the opposite, and the hypotenuse. That means we need sine theta, which is opposite of hypotenuse. Then we replace it, and we don't have the angle, so it's still sine theta. Opposite is 7, hypotenuse is 200. Therefore, we're just going to move the sine to the other side as sine inverse, 7 over 200. And you can plug this into your calculator like this. Sine inverse, open bracket, 7 divided by 200, close bracket, hit enter, and we're going to approximate it to 2 degrees. Now, our agreement is going to be degrees. We're going to do it to the fullest degrees, so no decimals. And when we find sides, we're going to do it to 2 decimal places. That's just going to be our agreement. So how do we solve a triangle? Well, that just means finding all sides and finding all angles. So see if you can go ahead and solve this triangle. We're given the hypotenuse, the adjacent, and I'm given, oh, and it's in the right angle triangle. That's it. I'm giving 2 things plus the fact that it's a 90. So I already put it the information that I have. And there's a couple of ways of going about it. You give it a try, and I'll show the answer in 3, 2, 1. So this is how I went about it. First, I look for angle R. And to find angle R, I notice that I will need the angle, I have the hypotenuse, and I have the adjacent. Hypotenuse and adjacent means cosine. So when I have cosine of R, because that's the angle, I got 10.5, which is the adjacent, over 15.2. I move the cosine over, cosine inverse, plug it in the calculator, and it was approximately 46 degrees. 46 degrees. Okay. Next, I said, well, if I have this angle and that angle, I know that the inside angles of a triangle is 180. So 180 is equal to 90 plus 46 plus Q. So therefore, we could solve for Q to be 44. And that was very nice and straightforward. And lastly, I realized that if I have 2 sides, to find out the next side, I can use SOHCAHTOA. But since I'm only dealing with 3 sides, I could have just used Pythagorean theorem. And I just, I noticed that the side that I'm looking for, which is R, here's something to point out. Big R is right across from little r, and big P is lowercase p, and Q is across from lowercase q. We call this triangle, so the sides, opposite side, opposite angle, will have the same letter. Just capitals for angles and lowercase for sides. And then just solving for it gives us this 1099. And it should be meters because we have the units. Okay? One last example. Peter is 1.5 meters tall. If he is standing 2 meters, 20 meters from a 38 meter tall tower, what is the angle of elevation from Peter to the top of the tower? So copy that diagram down. Now, if you have a picture, you actually want to draw a triangle beside it to give you a better representation. So I'm going to show the answer. Please stop it. Give that a try. In 3, 2, 1. Okay. The trick to this question was the fact to remember that Peter was 1.5 meters tall. So therefore, the height of our triangle was 36.5, which is 38, take away 1.5. We want to find out this angle, and we know that this is 20 meters distance to the tower. So, angle, opposite, and adjacent, because that's my opposite and that's my adjacent, which means we're going to use tangent, opposite over adjacent. Tangent of theta, I don't have the actual angle, and it would be 36.5 over 20. I just move the tan over, and tan inverse gives me 61 degrees, and that's the angle of elevation from Peter to the top of the tower. And just to finish, what is the most common pickup line heard among triangles? Are you thinking? Hey baby, what's your sign?